we talked, I think, already about the test format, but I'll just run through this again. So there's 10 multiple choice questions. There's split 7 and 3 from the calculator to no calculator section. So there's 7 multiple choice on the no calculator section and 3 on the calculator section. I've done that because there are some problems that we'll talk about today. I'll give you an example and show you how to do it. They can really only be done with your calculator, and the AP expects you to use your calculator to do these things. So we'll talk about how you use your calculator to do some definite integral problems. Okay? And then the subsequent test, you know, like the problems, because of the application nature of many of the problems, the directions will be like, draw this picture, write the integral you're going to use to solve this, and then use your calculator to find the solution to the definite integral. Because times consideration, I want you to, the setup is hard, and if I ask you to do potentially some difficult integral afterward, you just have a lot of time to do much. So that'll become a regular part of the class, and something they will give you on the exam or problems that must be done using the calculator, particularly in the calculator section. So we're going to talk about how to use that calculator here today for a few minutes. It's very easy. And then on the first part, there'll be one free response question. There'll be a multi-part free response question similar to the 5-3 homework quiz that I gave you guys. On the calculator section, you're going to have 7 integrals to compute. Some be indefinite, some will be definite, some will use substitution, some will not use substitution, all kind of mixed up with no real direction other than it to say like solve the integral. And you'll have to pick out what you have to do from looking at it. And then they'll have one free response question where I ask you to do some Riemann sum approximations from a table. Whether it's right hand or left hand or midpoint or whatever. Does that feel okay? So let's just start by showing you the calculator piece. Okay. So let's say I've asked you to compute. This is just like random, like calculator know-how stuff. Say I ask you to compute this integral. You have no antiderivative formula that can handle this at this point. And we could do this with u substitution, but not where you're at. This will be like a separate, like, hey, we're going to take, in the next chapter, take some time and talk about how to deal with the integrals of rational functions like this. Because right now, what do I do with this? The naive u substitution would be to take the x squared plus 4x plus 5. It's not going to work because you're going to have x's left over in your derivative that you don't have in the thing. So it won't work out very nicely for you. But our calculator can handle this. So if I pull up my graphing calculator, just shrink it down so I can look at it on the board. So I'm going to do this on the calculator. To get the integral symbol, I press the math button. And then I'm going to use command on my calculator's command number 9 that says fnint. That means function integration. And then I just type it in just like it looks like on my sheet of paper. and it'll spit out the definite integral. It can only do definite integrals. Can't do an indefinite one unless you have a one of the CAS calculators, which I don't know walking around that I've seen anybody using one. But if you're planning on being like a mathematics major, an engineering major, or something like this, a path where you're going to be doing like a lot of calculus for the foreseeable future, an investment in a good CAS calculator would be worth doing. So like a TI-89 or the Voyage 200 or the, I think they have the Inspire CAS edition, which I hate the menu system on. Give me a good old TI-89, which basically works the same way as the TI-84 does. It's I think the more convenient calculator. I don't know if they make them anymore, but you could probably find a used one available on eBay or something, which I think is pretty short learning curve compared to the Inspire CAS calculator, which I don't think is real intuitive to use. But that's it, right? So I promise you, on your test in the calculator section, there will be at least one problem where you'll need to do this in order to solve. So just kind of keep that in the back of your mind that like, hey, I can do this. And then really this can be used as a check or even on an indefinite integral problem, right?
Will we know which one we're supposed to use for, or are we going to have to see that if we can't do them?
Yeah, I'm not going to be that nice. I'll tell you that you're going to have to do it. I won't tell you when, though. I know. So let's say we have this like easy peasy integral, right? Now, like, you guys all know that this is the answer, right? So I can check this. So if I just say, I want to make sure to see if this is equal to my answer with the 3 and the 2 plugged in, right? So I'm going to do this on the calc and this on the calc and make sure my answers agree as a check for an indefinite. Right? So even if it asks for an indefinite integral, your calculator can't do that directly, but you can use your answer by hand, just like make it a definite integral and check it with your answer and the calculator's answer and make sure they're coming out to be the same thing or approximately the same thing. There may be like some decimal point approximation business because the calculator's not actually doing the calculus to do this. If we were in the BC class, I would talk about how the calculator is actually doing these things. But building a Taylor series to approximate this function, which again, like, is all agreed to you, but that's what's going on inside, or something similar. I guess it doesn't have to be a Taylor. Does that feel okay? You see how this could be useful, even to check stuff. As long as you have access to a calculator, that still makes the indefinite integral at least checkable right, wrong. It's not going to be the answer, but is reasonably checkable. You guys feel cool on the calculator piece? Yeah, I mean that's all I really wanted to show you guys. What do you guys want to do as far as questions go? Do you want to go through some of the AP style multiple choice and free response stuff? Do you have homework questions? Okay, let's start there then.
Okay. It was from the 5.3.
5.3? Sure. Hold on, let me pull up the textbook.
No, I can't. I haven't either. No, that's not what I was thinking.
Okay, what number in 5.3, Lucia?
69.
Okay. Oh, dang it. Dang it. Now let's do it.
No, I don't understand the rhyme song.
Oh, yeah, no,
Evaluate the limit by first recognizing the sum as a Riemann sum for the function defined on 0, 1. Okay. So what I want to do is I want to remember that like the integral of f of x dx from a to b is the limit as n goes to infinity of the sum from I equals 1 to n of was f of x I times delta x, right? This is our Riemann sum definition. Does that look familiar? And we said that delta x is b minus a over n, and xi is a plus I times delta x. But instead of writing delta x, I'm writing minus a over n. Is that okay? Okay. So if this is going from 0 to 1, I know that's like my a and my e. Okay? So if I do that, this guy becomes 1 over n, and this guy becomes I times 1 over n. You good there? Does everybody feel so far so good? So if I take a look at this, so I have a 1 over n that I'm going to take out of there. That's my delta x. I have a I over n, which I'm going to take out of there, which is...
Which one goes first?
Nope. Okay with that? So when I do that, then what do I have left? Oops. Okay. Now what I have left is I cubed over n cubed, right?
Did you put a 5 in there?
I decided not to, because this is going to be,
So please, why did it cube?
well, it was I to the third over n to the fourth, right? So I took one of the n's and put it there,
Okay.
so I have n to the third left in the bottom. Feel good?
Yeah.
So this is f of xi. So what is the f here if xi is I over n? F of x has to be x cubed. Okay? So this is just going to be the integral from a to b of x cubed dx. Which is something that we can do very easy. So rather than doing the Riemann sum, because that limit sucks. I don't want to do that. That was easy. Once I got it translated into an integral. Now, this is a great question you chose, Lucia, because I will also guarantee you on your test, there'll be at least one multiple choice question where you have to translate like one of these into an integral or an integral into one of these. So you stone cold need to have those formulas memorized. That xi is a plus I delta x, that delta x is b minus a over n, that the integral from a to b of f of x dx is the limit as n goes to infinity of the sum from 1 to n of f of xi delta x. So great choice, because it allowed us to talk about this, and this is something you'll have to do. Do you want to look through the multiple choice and see if there's another one like this to practice on? I'm sure there is. That's what the starter was. Is that? Go ahead.
I'm wondering where the A goes. Like, when you go from the first
So,
to the second.
A is 0.
Okay.
Because A was 0 and B was 1.
Yeah.
There was a number, like if there was an actual number for A instead of 0.
Yeah.
Is there an example of it?
Yeah, I think probably in the multiple choice. So I'm going to just kind of skim through here and look for what I'm looking for. You guys feel like this is good, what we're doing? It's like, do you know how to do this? And if the answer is no, then like this is probably time worth spent, right? Just kind of skimming here, looking for what I want. I might need to look at the second set of multiple choice questions here. I'm not seeing what I'm looking for yet. That's okay. Got a lot of them to skim through. Okay. I swear it was something that that I would have picked to put in here. Ah, there we go. Here we go. There's some. So 8 and 9 for sure. And then 10, 11. So there's a handful there. Let's just do 8 for the sake of argument as another example. And I'm going to leave you 9, 10, 11, and 12 to practice on your own so that I don't do all of them. You have to, like ride the struggle bus through one of these. Like once you see it, it's like, okay, I just really need the formulas and it should be okay. Okay. So if I take a look at this guy, again, I am going to say, for the piece that I need, and instead of writing it, I'm just going to write everything in terms of A, B's, and N's. I'm not going to have any Xi's in here anymore. Is that okay with everybody, or delta X's? Okay. So when I look at this, this part that's underneath the radical looks like this part that must be inside the function. Is that okay with you guys? So from that, it looks to me like A is 1. Let's buy that.
So this said they're not gonna tell you what A and B are. in the question.
Correct.
You have to do it.
Well, I mean, there's technically infinitely many choices because it's multiple choice.
Yeah.
I know that there's not really, I mean, it's either 6 and 1 or 5 and 0 is what they've given me, right?
Yeah.
So which one can I discard immediately? Yeah. How do I know that?
That is.
A is 0, B is 5. Here I've already come up with A is 1. So I've already knocked this down to a 50-50 guess, which is pretty exciting when I can do that in a multiple choice question inside of like, you know, looking at it without having to do any real arithmetic here or any kind of calculus. If I just kind of know what the form looks like, and they'll be like, okay, well that looks like my A. All right, so far so good? Okay. So that means that my xi would be then 1 plus I 6 minus 1 over n, right? Again, this is the same as that highlighted stuff. I guess they're calling it a K. Should I use K? Is that confusing to switch to I?
Oh, because I don't know.
Because it's got to be 5, A is 1, I know B has to be 6, right? Plus we've eliminated those other two. Like either way of thinking about it, I know B is 6. Is that okay? So if that's the case, can it be 2x in front? I have 2 times 1 plus 5k over n. Am I going to get the right thing? Doesn't look like it.
How do you know what n is?
We're never going to know what n is. N is like the number of slices we're going to make for our Riemann sum, which is always going to infinity. Right, that's not going to work, is it? Right? Because I'm not going to have the 10k over n, but I have this extra plus 2. Correct? If I do it here, I have the 10, but I'm not going to get the k over n. You know what we did? Because look at the way this is set up.
So what happens at A being 1?
Well, what if we look at it instead as this is my xi?
That's what we did.
No, we said the whole yellow was our xi before. Because if I look at my other two options, I have 1 plus x, right? So if xi is that case, then A is 0 and B is 5. Looks okay. That means xi is going to be just k times 5 minus 0 over n. So that looks good there, right? That's going to get us the 10K over N. That guy is just going to be 5K over N. So the 1 plus, right? And then my dx is my delta x, which should just be 5 over N. Looks like it's going to be that. So it's just kind of about peeling it apart, but you got to know those formulas about like what is xi, what is delta x, what is the Riemann sum going to look like, to be able to kind of peel that apart. And notice in the beginning, my first instinct was, okay, the stuff under there is going to be the xi. And when we assumed that, and I checked it, neither one worked, right? So I had to, okay, well, then that can't be the xi underneath there. I'm going to have 1 plus xi, which is what I had as my option here. If I do that, the a is 0 and it's
So this could be like the type of thing on the Riemann sum effort here.
no, this would be like a multiple choice question.
Okay.
Is where this would fall in. Would not give this to you as a, like, do it from, I need to give you more than what they gave you if it's not a multiple choice question, because there's no way to find the A and B could be literally any numbers that are 5 apart. Like, unreasonable for you to cook that up on your own without the multiple choice ability to be like, okay, it's either gonna be 6 and 1 or 5 and 2, or 5 and 0. Like, if it's anything, it could be like 7 and 2. Could be 5.5 and 1, or 0.5. Could be, 5.1 and negative 0.1. Like it's literally terrible, like impossible without it. I mean, maybe you could luck into it or something, but like, it'd be terrible. Yeah. This kind of needs to have the multiple choice structure, unless I give you the A and B at the start, like we did on the homework question. Is that okay with everybody? The other way of approaching this that maybe is easier is, what if we did this? The other way you could do this is start with your answers. So I could just kind of do this one at a time. It's like, okay, if I assemble this then, like this integral would give me this Riemann sum. That's not it. And then just could go down one at a time. You could also approach it that way, where you start at the Riemann sums and go back, or start at the integral and go backward to the Riemann sum. That might be easier of an approach, because it's just like, I'm just using the same formula over and over and over again with just different integrals and building the Riemann sum out from it, rather than starting with the Riemann sum and having to like strip the pieces apart to get what I need. It's a little bit less of like a mystery in that case. It's just like a guess and check, or just like a checking. I'm going to do the same decoding and check to see if it actually gives me the thing that I'm looking for. It's probably a little easier, at least in a time test setting, where maybe in the worst case scenario it takes, or in the like average scenario it might sorry. The quickest it's ever gonna go is probably gonna be slower than if you just look at it and be like, which one is it gonna work? But if you're not good at doing that quickly, this is probably safer. Because the average time on this is probably gonna be quite a bit faster, because if you don't see it doing the other way, it's just gonna take you a long time to kind of piece that together. And the ability to make a mistake, like in the beginning where we assumed that A was 1 and then we found out like, oh, that actually doesn't work, that can't be what it is. You kind of protect yourself a little bit from that, making a bad assumption there if you go that route. So maybe that's the better approach. Would you like that a little bit better? Just kind of grinding through and doing the check, using the answers to try to build the question back out of it. It's a little bit more straight line to do it that way. Okay. Lucia, did you have other 5-3 questions, or was that the big one? This all stemmed off of one question from long ago.
There was a 73 and I think a 76, and you're both like
kind of the same idea.
Yeah.
Okay. Well, we typically, Mr. Kulik assigns them for a reason. 73 and 76 were the two. Let's grab both of them and make sure okay. So the idea with 73 is I would be using, just find the thing that I want. Here's what I'm looking for. Is it not in this section? Is it in the next section, or was it in the previous? Oh dear. Okay. It's here. Ah, perfect. This is what I'm looking for. So I'm going to use these properties. It would be my plan.
You can memorize it properly?
Well, here's the idea. That if I have a function bounded between two values, that's what they gave us, then the integral should be bounded between those two values. Right? If I take the integral of m, integral of f, and integral of cap m, that'll still be bounded between them. So that is the tool that I think I'm going to need here. Show that 1 is less than or equal to this thing for x greater than 0. Let me look at this one. Yeah. Except we have x greater than 0. What do I do with this? What do I do with that? What do I do with this? Let's look at it one more time. Okay, well, I think that to do the second part, to do part B is the easier piece, because that, all I need is this guy. I'm going to use my answer for part A, and then just do this with it, right? I see that now. So this is 1, and this is going to be like x plus x to the 4th over 4 from 0 to 1. So I'm going to have 1 plus 1/4 minus 0 minus 0. So that's that, right? This is, I'm just going to do a squeeze theorem.
Oh my gosh, I'm so horrible.
It's giving me this guy, right? What's that? So we go back. Let's go back and read the squeeze theorem again, right? This guy maybe. Oh no. If then we get the limit, we're not looking for a limit. That's not what we need at all. What's that? You're going to call off school?
If I had the power.
All right, well, let me think on that for a minute.
Okay.
Let's look at 76. So let f of x be this yucky looking piecewise function and g of x be that integral function. Find an expression for g of x similar to the one for f of x. Okay? So I'm just going to do like the integral of each one of these. So if my function is 0, the straight line y equals 0, what's the area under that? 0. Right? Okay. If we're x from 0 to 1, it's going to be 1/2 base times height. And the height is x, and the height, or the base is x. Same thing here, just like a triangle. And that ought to do it, I think. I don't want to sketch the graphs, is that okay? Where is f differentiable? It's a good review question. Each one of these three, or each of one of these four functions is differentiable on their own, correct? The only thing I have to worry about is their boundaries. So at x equals 0, I have 0 on the left, my limit is 0 on the left, my limit is 0 on the right, and f of 0 is 0. So we're good at 0. If I look at 1, my next boundary, on the left the limit is 1, on the right the limit is 1, and at 1, f of x is equal to 1, so it's continuous there. And then at 2, if I plug 2 in, that's 0 and 0, and then f of 2 is 0, so we're continuous all the way through. So we have that. So we don't lose any differentiability because of continuity reasons. But now we have to check for corners, right? So here, the left, if I look at the derivatives, zero, 1, negative 1, 0. Everybody okay? So the slope at 0 changes from 0 to 1 abruptly. What is that going to be? A corner, right? It's going to go like that. At 1, the slope changes from 1 to negative 1. What is that going to mean? Corner. And then from at 2, the slope is going to change from negative 1 to 0. That's a corner. So we're just not differentiable at 0, 1, and 2. Where is g differentiable? So I would just kind of do the same thing. I take the derivative of g and look at the, well, I have to check continuity first, but it should be kind of continuous everywhere. But then I need to check the pieces, the derivatives. Do you feel okay on this?
Yeah.
Nothing this nasty would be on the test. There's no proved questions. Like the first one where it's like, show this, if this. No, they're not gonna ask you that. He's not, they gotta ask you to do that. Aside from a few like obvious, like you have to use the intermediate value, for the mean value, where you're like, where it's an obvious theorem situation. What else would you guys like to do? Yeah,
Can you do more of the AP questions?
multiple choice or FRQ?
Oh. I don't know. Whatever you do, can do more.
I think that because we did those 5-3 questions in the homework quiz, let's do multiple choice for now. We haven't really practiced a whole lot of those this chapter. I mean, you have, but like, I don't know, people asked already, Lucas asked about a bunch of the FRQ stuff already once, and we did one of them already once. We haven't really done any MCQ stuff together. Does that feel okay? Scroll up to the top. What do you notice on this question? Calculator. What is that going to mean for us? Means that we're probably going to need to use our calculator to do part of this problem. Okay. So for b between 0 and 2, we're asking where is the function having minimum? To do that, what am I going to use to find a minimum? First or second derivative test, right? Specifically, I'm going to think about this function as like like f of b is this. So I need to know where f of b, or f prime of b is equal to 0, or where f prime of b does not exist, right? What is the derivative of this? What's f prime of b? Yes, just cosine, like in this case it would be like e to the b, since we defined it as b. But remember, the derivative just cancels out the integral. And since our variable in our integral is just like a linear term, no chain rule necessary, right? So if I know cosine is defined for all values, right? And exponential functions are defined for all values, so this is a big fat none, right? Okay, so I just need to worry about where cosine e to the b is equal to 0. So I'll do like cosine inverse of both sides. Cosine inverse of 0 is it is 1, but technically plus 2 pi k for all integer values k. Now, b is stuck between 0 and 2. We got to remember that, but we haven't got b by itself yet, right? So what do we need to do to get b by itself? Natural log both sides. And this is where I'm going to need my calculator. So when k equals 0, I'm just doing the natural log of 1, which I know what that is. When k is equal to 1, I'm doing the natural log of 1 plus 2 pi. Oh my God. Cosine inverse of 0, that should be pi over 2. That should just be plus pi k. Yizers! Yizers! Right? Cosine of 0 is 1. Cosine inverse of 0, or cosine inverse of 0 is pi over 2, or 3 pi over 2, or etc. Right? So these are both, I'd have to check these on my calculator, right? Okay. Do I need to worry about this one? Nope. Why not?
It's over 2.
It's over 2. Okay. Is that 0.45 or 0.045? Those two. Okay. What do I still have to worry about though? Well, I am going to want to check that, but there's something else I need to worry about first. Because this is a closed interval, what else do I have to consider? Endpoints. So I'm going to need to do f of 0, f of 0.452, and then f of 2. How am I going to do that? I'm going to do that fn command on my calculator. I just take the one that is the smallest of the 3. 9 going 0 to 0. Cosine of e to the x, oops, dx, so I know that one. And we'll change that to 0.452. And then we'll do 2. So what's my winner? A is the smallest. And good gravy, I hope I did that right. Nope, I didn't. Why didn't I do that right? How the heck did I get it wrong? Oh, no? Where's the mistake at? Who sees it? Oh, hold on. I'm so dumb. Look what I did. It's only supposed to be a 1 pi. I missed one. Right? I wrote it right here. I didn't type in the calculator correctly. Ugh. Who's done that before? Okay. Oh my God. This is the real problem. Look at the mode. Yeah. I was like, that didn't work out right either. What the heck's the matter? I'll tell you what's the matter. Teaching pre-calculus is the matter. This class, always radians. No degrees in AP calculus. Always radians. All radians all the time. All right. Hey, test. When are we doing it? Tuesday next week. Test. Done. We'll do this also. We'll plan on 20 or 30 minutes doing some review stuff Wednesday and Friday in addition to the news.
Here we go. Some real math now.
We're finally into some real calculus here. We can do integrals. You're welcome.
Don't we all love integrals? If we got to integration by parts?
We've done use sum.
I don't like use sub. But I don't have an issue with use sub or integration by parts, but when to use them.
That's the hard part.
Like when you're not told.